Okay, today we'll start Poisson distributions, second part. Poisson distribution, second part. In previous lecture, we have studied about the Poisson distribution, first part. Um, Before that, we studied about binomial distributions as a part of uh, probability distributions. So today we'll finished the second part of Poisson distribution. Um, Connecting with this, we'll study about the real life application of Poisson distribution in this part, and discussed different types of examples for that, which is really uh, applied in our real life. Um, in previous, we discussed we solved 4 example in this part as a part of first part. Now rest of the part will be started. Now example 41. This is also application of Poisson distribution. The number of arrivals of customers during any day follows Poisson distribution with the mean of 5. What is the probability that the total number of customers on 2 days selected at random is less than 2? Okay. Now the mean, we already know that mean is denoted by small m. Okay. This is the mean of Poisson distribution. Mean is given m equals to 5. Now probability density function for Poisson distribution, we must know the probability of r equals to e to the power minus m to the power r factorial. This is the probability density function of Poisson distribution. Now putting the value of m, mean m equals to 5, we get this result. Now if the number of customers on the day 2 is less than 2, right, less than 2, this is why we can consider the probability for 1 or 0, right, since less than 2 means we have to consider 1 r equals to 1 or 0. Now for the first day and second day total, so first day r equals to 0 and second day also 0, this means 0. Now for the first day, if r equals to 0, then second day may be 1. Okay, in first day may be 1, second day 0. So in the both case we get the total is 1. So the required probability can be taken as probability of 0 multiply probability of this first day 0 into probability of second day 0 for the first case. Now for the second case, we can take probability of 0 for the first day and probability of 1 for the what, second day. Probability of 0 into probability 1. For the third case, similarly probability of 1, this multiply with probability of 0. Okay, now probability of 0, that means r equals to 0 in the Poisson distribution function, probability density function of Poisson distribution, just putting r equals to 0 here, and also putting r equals to 0 here, we get same term. Now probability of 0, r equals to 0 in the density function, and r equals to 1 in the density function will give this result. Similar process, just putting r equals to 1, we get the same result. Then probability r equals to 0, then probability of 0 will be given this by this term. Now after calculating something to the power 0 equals to 1, and 0 factorial means of course 1, you must know about it, and 1 factorial of course gives the result 1. This is why you get the same term like this, just adding, we get 11 e to the power minus 10. Just using scientific calculator, we get the e to the power minus 10 equals to this result. Actually this is the required probability, where the total number of customers on 2 days selected at random is less than 2. This is the probability. Okay, next example 42. Using Poisson distribution, find the probability that the ace of spades will be drawn from the pack of well shuffled cards at least once in 104 consecutive trials. That means total number of trials or events and equals to what, 104. We must know actually total number of spades in a total number of cards, what? 52 cards. Okay. Total number of cards, everybody know 52. So probability of the ace of spades, single ace. Okay, 1 by 52. Right. Now m equals to what? Np. Mean equals to np. We have proved the result by using probability density function of Poisson distribution. Mean m equals to np. We have proved it in our previous class. M equals to np, just putting, we get the mean equals to 2, just putting these two values. Now probability density function for Poisson distribution, Pr equals to, we must know this, e to the power minus m into m to the power r divided by r factorial. So putting m equals to 2 and r, we get this result. So we have to find out the probability that the ace of the spades will be drawn from a pack will shuffle at least once. Okay, probability of at least once will be probability of 1, probability 2, probability 3, up to probability of what? 104. That means total probability. Total probability we have to find out. We must know total probability. In any case, total probability is 1, right? Total probability of 1. If we subtract probability of 0, then we get this whole result. If you try to find out the individual probability by using r equals to 1 here and r equals to 2 here, but it will be very, very time consuming for us. So if we apply a technique, just total probability 1 minus probability of 0, then we get the whole result. Thus probability of 0, what will be? Just putting r equals to 0 here, then 1 minus 1 by e square 2 to the power 0 into a 0 factorial, then gives the result. Understand, everybody?
Yes, sir.
Now next example 43. In a certain factory producing cycle tires, that means there is a factory of cycle tires, there is a small chance of 1 in 500 tires to be defective. That means out of 500, 1 tire is defective. The tires are supplied in lots of 10. Supplied in lots of 10. Using Poisson distribution, calculate the approximate number of lots containing no defective. That means we have to calculate the approximate number of lots containing no defective. 1 defective and 2 defective. That means no defective first case, 1 defective second case, and 2 defective third case respectively, in a consignment of 10,000 lots. Actually, there is a probability of one tire is defective out of 500. So probability of defective, what will be? 1 by 500. Now n equals to what? Lots what? For this probability, 10. 10 is the total lots. So lots, the tires are supplied in lots of how many tires? Actually 10 tires. So we know mean equals to np. This is why we get 0.02 is the mean. Now we know the probability density function for the Poisson distribution is this, e to the power minus m into m to the power r factorial. Now for the first case, probability of no defective, that means probability of 0, we have to find out. Just putting r equals to 0, we get the result. Number of lots of containing no defective, out of 10,000, no defective will be this probability multiplied, then we get how many lots will be no defective? 9,802 lots. Similarly, for the second case, probability of 1 defective, probability of 1, that means r equals to 1 in the probability density function of Poisson distribution. Just putting r equals to 1 here, we get this result. Then just multiplying with the what? Mean. Then we get the probability of this. So number of lots containing one defective, what will be? 196 lots. That means total defective will be 196 for the probability of 1 defective. Now the probability of 2 defectives, probability of 2, just putting r equals to 2 in the probability density function of Poisson distribution. This r equals to 2 and m equals to 0.02. So we get 0.02 whole square equals to this. Then multiplying with this result, we have to calculate this with calculator and scientific calculator, of course. So then we get the result. Just multiplying with this, we get the probability of 2 defective is this. Now number of lots containing 2 defectives, total lots 10,000. So if you multiply this probability, then we get 2 lots is the, actually we get 2 lots is the total defective. Okay, very easy. Just putting r equals to 0 for the first case, r equals to 1 for the second case, and r equals to 2 for the third case. And then the probability, if we multiply to the total, then the result will give the number of lots, right? For 1 this, for 0 this, and for 1 these lots, and for 2 defectives these lots, 2 lots only. Okay, understand?
Yes, sir.
Next example 4, a car hire farm 2 cars which it hires out of day by day. Okay, a car hire farm has 2 cars, 2 cars which it hires out day by day, and the number of demands for a car on each day is distributed as a Poisson distribution with the mean. Mean is given, m equals to 1.5. Calculate the number of days in a year in which, number 1 we have to find out car is not used. In the second case, the number of days in a year on which some demand is refused. Now in this connection to this question, we have to find out, we are given mean equals to m equals to what, 1.5. Now for the first case, if the number if the car is not used, then the demand r equals to what will be 0, right? If there is no car used, so probability of r we know from the probability density function of Poisson distribution is this. Putting r equals to 0, we get probability of 0 equals to this. This is the actually probability for the car is not used. Now number of days in a year when there is no demand of car. Actually total days, how many in a year? In a year, how many days? 365 days. This is why if we multiply with this probability, then the number of no demanded car will be this 81.4315. But the total number of car can never be fraction. This is why we have to take it the whole take as a whole number. That means 81 days. Okay. Now some demand is refused if the number of demand is more than 2. That means days, if the number of days in a year on which some demand is refused. So for the second case, some demand is refused if the number of demand is more than 2. For the 2 car is demanded, okay, but more than 2 will be not demanded. So r equals to greater than 2. Now we have to find out the probability of r greater than 2. That means up to r greater than 2 means 3, 4, 5 dot dot etc. up to what, many days, up to 3 for the 365 days. So if we find out if we try to find out the whole probability of this, just this equal to will be total probability 1 minus probability of 0 plus probability of 1 plus probability of 2. If we subtract these three probabilities from the total probability 1, we get the our required result, right? Just 1 minus probability of 0, what will be, just putting r equals to 0 in the probability density function of Poisson distribution, we get this. Then probability of 1 will be r equals to 1 here. Okay, we get this. M equals to given 1.5, but probability of 2 will be for r equals to 2. Okay, this will be the, just calculating this with calculator, we get the result. Then taking common e to the power minus 15, 1.5, then we get this result. So number of days will be, just we have to multiply this probability with what, days of year, that means 365 days. 365 days multiply with this, how many days will be, this is approximately 70 days, right? look like 70. Approximately this can be written as 70. This is why 70 days will be the demand is refused. Understand everybody? I hope very easy for you, just using the formula of probability density function of Poisson distribution. Now next example, if the probability that an individual suffers a bad reaction from a certain infection is 0.001, determine the probability that out of 2000 individuals, out of 2000 individuals will be number exactly, we have to find out the A, number A exactly 3, number B more than 2 individuals, number C none, number D more than one individual will suffer a bad reaction. Okay, now if the probability that an individual suffers a bad reaction from a certain infection is this, that means a given probability is P equals to 0.001, but n equals to total number of individuals, that means patient, total number of patient what, 2000, right? Total number of 2000. So we can write the mean m equals to mp. This comes from where? Actually, we derived it from Poisson distribution. So just m equals to, we get result 2. Now we know from the probability density function for Poisson distribution, P r equals to this result. Now putting m equals to 2, we get this. Now probability exactly 3. So if r equals to 3, then we get the result is this. This is the probability. Now more than 2 individuals. So more than 2 individuals means for the more than 2 means 3 patient, we can take 4 patient or 5, up to 2000 individuals. So calculating this sum, actually how many terms here? How many terms? 1997 terms. So very difficult for us to calculating, but we should apply a technique. Just we must know the total probability is 1. Just if we subtract probability of 0, 1 and 2, then we get the result for this whole sum of probability. Just probability of 0 plus probability of 0, 1 plus the probability of 0 is subtracted. This sum is subtracted from the total probability 1. Understand? Now for r equals to 0, 0 individuals, if we consider, then this result, just for r equals to 0, we get this. For r equals to 1, on the probability density function, we get this, and probability r equals to 2 individuals, we get this. So after calculating e to the power minus 2 in each term consist, so we can take common, then something to the power 0 equals to 1, then 2, and this cutting 2 will be cancelled, the 1 is 2. This is the 5 actually. Then after calculating, e has a value, you must know, in scientific calculator you can find the value of e. So the probability for more than 2 individuals is this. Now number C, none. None means what? Probability of non individuals means what? R equals to 0. Very easy. Just putting r equals to 0 in the probability density function for the Poisson distribution, we get this result. Now another item, more than one individuals will suffer a bad reaction. What will be the probability? Okay, more than one means what? Probability 2 plus 3 plus 4 dot dot up to what? Probability of 2000. So this actually finding this sum is very difficult for us, but uh, if we apply a technique, that means this total probability is 1. So if we make the subtraction, probability of 0 plus probability 1, then this will give the very easy result. 1 minus probability of 0 plus probability of 1. Thus subtracting these two from total probability of 1, we get the whole sum of the probability. Now probability r equals to 0, for 0 putting the value of 0 here, r equals to 0, then we get the this, and for r equals to 1, this. Just subtracting these values, sum of the values, then e to the 1 minus 2 will give the, this is the probability 0.595. I hope very easy. Now next example, 46. A manufacturer knows that razor blades he makes contain an average 0.5% of defectives. That means a manufacturer of razor blades, he packs them in a packets of 5. That means n equals to 5. What is the probability that a packet picked at random on will contain 3 or more faulty blades? Faulty blades means defective. So probability is 0.5%. 0.5%. That means 0.005 after dividing with 100. Total number of pack what? 5. So mean what? M equals to NP. We must know 0.025. Now we know probability density function for the Poisson distribution, e to the power minus m into m to the power r factorial. That means just putting value of m, we get this. Now we have to find out the probability of which will contain 3 or more faulty blades. That means probability of 3 or more. 3 or more means what? 3 plus 4 plus 5. Actually 5. Okay, total number of 5. So if we take the sum of these 3 probability, we get the our desired result. Now just putting r equals to 3 in the probability density function of Poisson distribution, we get this. R equals to 4, r equals to 4, then we get this. For r equals to 5 in this probability density function of Poisson distribution, we get this. Now e to the power minus 0.025 is the common to all. Just taking cube, taking 4, taking 5, calculating with calculator, we get this. So the probability is very negligible, very small, negligible probability. Okay, now next example. Suppose that a book of 600 pages contain 40 printing mistakes. Printing mistakes, how many? 40 out of 600. So probability will be what? 40 divided by 600. That means favorable sample divided by total sample. So this is the definition of classic probability. So for this will give 1 by 15 is the result. Assume that these errors are randomly distributed throughout the book and X, and the number of errors per page has a Poisson distribution. What is the probability that 10 pages is selected at random? That means n equals to what? 10 pages. 10. So what is the probability at random will be free of error? Within 10 pages I selected, there will be no error. Error means printing mistake. So m equals to what will be np? 2 by 3 is the mean of the Poisson distribution. Now Poisson distribution function e to the power minus m to the power r factorial. Just putting m equals to 2 by 3. Okay, we get this. Now probability of 0, that means no mistake, no error, no printing mistake. Just r equals to 0. Putting r equals to 0, we get the result 0.51. That means 50% probability. Now another example, 48. A manufacturer knows that the condensers he makes a contain on an average 1% defectives. Okay, how many defectives? 1%. He packs them in a boxes of 100. What is the probability that a box picked at random will contain 4 or more faulty condensers? Now probability is what? 1% of defective. 1% means removing percent, we get 0.01. And total number of box packs what? 100. So n equals to 100. So we get the mean is 1. Just mean of Poisson distribution. Just m equals to np. We derived it earlier lecture. M equals to np equals to 1. So probability density function for the Poisson distribution, same density function. This is the putting m equals to 1. We get this one. Okay. Something 1 to the power something equals to only 1. Remember it. Now we have to find out what is the probability that a box picked at a random will contain 4 or more faulty answers. 4 or more. That means 4 or more faulty answers means what? Probability of 4 plus probability of 5 up to what? Probability 100, because 100 packs. Total 100 packs. So if we take if you want to find out the sum of this whole probability, total probability is 1, right? Total probability 1. Then if you take the subtraction from 1 of probability of 0 plus probability of 1 plus probability of 2 plus probability of 3, then this subtraction will give the total probability of this, right? Just putting r equals to 0 in this probability density function, we get this one. Probability of 1 will be r equals to 1, r equals to 2 will give this, r equals to 3 will give this. Then e to the minus 1 are the common, right? This is the 1, factorial 0 means 1, factorial 1 means also 1, factorial 2 means only 2, factorial 3 means what? 3, 2, 1, just 6 multiplication. Then we get this result. Now another example, an insurance company found that only 0.01% of the population is involved in a certain type of accident each year. If its 100 policy holders are randomly selected, sorry, 1000 policy holders randomly selected from the population, what is the probability that not more than 2 of its clients are involved in such an accident next year? That means actually insurance company always work for accident. This why probability of what's is 0.01%. That means if we remove percent, we have to divide it with 100. This is why 1 by 100, 1 by 100, right? Now 1 by 10,000. Now total number of population, what? Policy holders, total number 1000. So if we want to find out the mean for Poisson distribution, m equals to np equals to just 0.1. We know probability density function for the Poisson distribution is this, just e to the power minus m to the power r divided by r factorial. Then we get if you put if you want to find out the probability not more than 2 of its client, not more than 2, that means what? Not more than 2 means probability of 0 or and probability this will be or, not and. This will be what? Or. Probability of 0 or 1 or 2. This is a mistake, printing mistake. This is not will be and. This will be what? Or. Because not more than, not more than 2 means maybe 0, maybe 1 or maybe 2. This will be what? Or. In replace of or we use plus or union in set. Now this will be what? Probability of 0 plus probability of 1 plus probability of 2. Just putting r equals to 0 in probability density function, we get this, and r equals to 2 1 for this, r equals to 2 for this. Okay, just u to the power 0 0.1 will be common from 3 terms, then you get this, the total probability. Now very important example for you, the is 50 is the a skilled typist actually on routine work kept a record of mistakes made per day during 300 working days. Mistakes per day 0, 1, 2, 3 up to 6 per day. Number of days, this number of days, this is the mistake per day. Okay, so number of days are given in the second row. Fit a Poisson distribution to the above data and hence calculate the theoretical frequencies. We have to fit a Poisson distribution to the above data, hence calculate the theoretical frequencies. Now the mean of the number of mistakes, actually mean of the number of mistakes, what will be? 143 multiply 0, 90 multiply 1, 42 multiply 2. This is the per day. This is why number of days. Per day mistake what? 2. So total mistakes what will be? 42 multiply 2. This is why. And then 12 days per day mistake what? 3. So 12 days total mistakes will be 36. Then this multiply, this multiply, this multiply. We get the total 267. But total days what? Total days, number of days, total number of days what? Take sum this, maybe 300. So the this sum divided by 300 will give the actually mean of the mistakes, mean m 0.89 will be. Okay, now number of mistakes in first column up to 6, and probability density function for Poisson distribution we are e to the power minus m, right? E to the power minus m, m to the power r divided by r factorial. M is the actually mean. Okay, 0.89. Now theoretical frequencies we can calculate for the r equals to 0. R equals to 0, we get this result. Then this multiply with 300, we get 123 approximately, right? Then after multiplying with r equals to, after putting r equals to 1 in this probability density function, we get this. Then multiplying with 300, since total days 300, this is why probability only 110. Then up to 6, putting r equals to 6 in the Poisson distribution function, then you get this result. You have to calculate it with calculator. You have to use calculator. Okay. Then we get multiplying with 300, 0.09, approximately 0, right? This is approximately 1. This is approximately what? 3. And this is approximately only 14. And this is approximately can be written as 49. Okay. And this will be 110. Remember it after point. If 5 or more than 5, the number, then we can write the number of the post number of that consecutive post number. So we have fitted a theoretical frequencies. This is the theoretical frequencies. If we take the sum of this, we get the total number 30. Okay, total number what will be 30. 1 3 what 4 4 4 means what 8 8 8 are 3 11 11 means 9 plus what will be 200 200 0, and there will be 2 in hand, 2 2 4 5 9 10 0, then back 1 2 3. So total will be what 300. Number of total frequency will be 300. Understand everybody? Now similar process, fit a Poisson distribution to the following data, which gives the number of yeast cells per square for 400 squares. Number of cells per square 0 to 10, and number of squares are given. Up to total what? Total what was? Total 400. If we take the sum of this will maybe 400. It is given that e to the power minus 132 equals to this. Now solution, x values, the serial number, and f frequency given 400, and f into x. That means multiplication will be this. Mean equals to m equals to mean will be what? Summation fx divided by summation f, right? If we take this sum, we get 529. So summation fx will be 529 divided by 400 will give the mean m equals to 1.32. Now, but Poisson distribution function, probability density function for the Poisson distribution, we know p of x equals to e to the power minus m to the power x, m to the power x divided by x factorial. There is a not r. If this is r, this will be r. Okay. So there is will be x, mistake, printing mistake. So we can write e to the power m equals to what? 1.32, and m equals to 1.3 to the power x divided by x factorial, right? So probability of x will be, this will be x, right? Probability of x will be this. E to the power minus 1.32 are given. This is actually from calculator. You can found from calculator after calculating 0.2674 will be. Okay. Now we can tabulize this, the information from the above, look like above example. First column will be number of cells, and second column will give the probability density function for the Poisson distribution, then theoretical frequency is calculated for x equals to 0, that means r equals to 0. Okay, then we get this, no? And this something to the power 0 means 1, 0 factorial means 1. This is why only this result 0.2674. Then multiplication with the total number of frequency 400, we get this 107. Then r equals to, if x equals to 1 or r equals to 1, this will give after multiplication 141. Then r equals to 2 will give this, r equals to 3 4 5 up to 10. Okay, then r equals to what will be 10, or x equals to 10. will give this result. Very, very negligible. After multiplication with 400, what will be? This will be 0. Very, very negligible. This is why 0.001, 00 something. That means very negligible, near to 0. This is why 0. This is also near to 0. And this also what? Near to 0. This also near to 0. And this what? Near to 1. And this what? Near to 4. Right? And this will be what? What? Near to 14. And this is the whole number 41. And this will be near to what? 93. You have to write this as 93. After taking sum, you will get 400. Actually, this is the result. Okay, you will try at home this exercise. I hope everybody can do this after solving our previous example. I have studied. You can solve this 1, 2, 3, 4, and 6 mistake per page. Look like this above example. Okay. Okay, try at home. I hope everybody can do this exercise, just similar to example. Okay, another example, a manufacturer of cotton cotter pins. Okay, cotter pins knows that 5% of his product is defective. If he sells cotter pins in boxes of 100 and guarantees that not more than 10 pins will be defective, what is the approximate probability that a box will fail to meet the guaranteed quality? So we are given total number of pins in the boxes will be 100, and probability is given 5% only, and mean m, this actually m or lambda, anyone, mean will be what? Np. So np equals to what? N means total number of pins 100, and 0.05 is the probability, so we get only mean 5. So p is very small, we may use depending on mean probability, depending on mean, we have to use probability distribution. So Poisson distribution can be applied here. Probability of x defective pins in boxes 100 will be, probability of x will be, this is the probability density function for the Poisson distribution, right? E to the power minus m to the power x expected, same. Okay, in replace of m we are using lambda here. Actually lambda mean equals to 5. Okay, then x equals to up to infinity. Now probability that a box will fail to meet the guaranteed quality is greater than 10. Why? Actually guarantees that not more than 10 pins will be defective, not more than 10. This is why probability will be x greater than 10. X greater than 10 means what? 1 minus probability of x less equal to 10. Probability of x less equal to 10. So 1 minus x less equal to 10 will be what? Just r equals to 10, right? r equals to 1 to 10, x equals to 0 to 10. That means probability of 0 plus, probability of 1 plus, probability of 2 plus, up to what? 10. Then e to the minus 5, x equals to 0 to 10, 5 to the power x divided by, this is the actually result. Similar process, 6 coins are tossed 6,400 times. Using the Poisson distribution, find the approximate probability of getting 6 heads r times. Just using probability density function for Poisson distribution, we get the result. But mean will be what? Np. Np means, n means what? 64,000. P means what? Actually 6 coins are tossed. So probability of head equals to half, probability of tail also half. This is why total probability will be 1 by 2 to the power 6, because 6 coins. Understand? Half multiply, half multiply, half multiply. How many times? 6 times, because 6 coins. This is why total probability will be half to the power 6. So mean will be what? Np. Np means 100 only. So just putting the mean lambda and we get the result. R will be 0 to up to infinity. Similar process, example 27, errors in pages. This is also can be, we have studied an example like this. In a book of 520 pages, 390 typographical errors occurs. Okay, so total probability, what will be 390 geographical errors occur. Assuming Poisson law for the number of errors per page, find the probability that a random sample of five pages will contain no error. The average number will be, what will be 390 divided by 520, 0.75. This is the actually mean lambda, mean. Hence, using probability density function for the x error, probability of x will be e to the power minus lambda, lambda to the power x factorial. X means actually r in, for our previous example. So e to the power, just putting the values. If for x equals to 5, okay, then putting x equals to 5 here. 5 pages will contain no error. Is given by no error, x equals to 0. That means 5 e to the power 0 minus 0 minus 0.75 to the power 5. Okay, x equals to 5 factorial divided by 5 factorial. We get this result. Okay, is a Poisson distribution has a double mode, median mode, this mode, double mode at x equals to 1 and x equals to 2. What is the probability that x will have one or other of these two values? Actually look like theorem. We have proved that if the Poisson distribution is bimodal, then the two models are at the points x equals to lambda minus 1 and other is x equals to lambda. Bimodal, if bimodal, then one x will be lambda minus 1, other will be lambda. Look like total sum, what will be 1? Total sum 1. Since we are given that two modes are at the points x equals to 1 and x equals to 2, so we find that lambda equals to what? 2. Lambda equals to 2, comparing with this. So probability density function for the probability density function for the Poisson distribution is this e to the power minus lambda, lambda to the power x divided by x factorial. So just putting lambda equals to 2 for the x factorial we get. For x equals to 2, x equals to 1, we get this. Just putting 2 to the power 1 and 1 factorial, we get this. For x equals to 2, we get this. So required probability will be sum of these two. If we take sum, then we get this. Very easy. If x is a Poisson variates such that probability of x equals to 2 equals to 9 into probability of x equals to 4 plus 90 into probability of x equals to 6, then find mean. That means lambda and beta coefficient of skewness. Very important question for you. If x is a Poisson variate, that means we know probability density function for the Poisson distribution. That means Poisson variate, same words, e to the power minus lambda, lambda to the power x to the power x factorial. This is the actually previous density function. X will be started with 0 up to infinity. Lambda will be of course greater than 0. That means mean of course 0 means mean of course positive. Hence this gives actually e to the power minus lambda, just x equals to this equals to from given equation 1. This you can name the 1 equation. X equals to 2. If we put x equals to 2 here, we get left hand side, right? This equals to 9 into x equals to 4. Okay, 9 into x equals to 4. If x equals to 4, we get this. Just taking common e to the power minus lambda from both sides. And if x equals to 6, then we get, okay, just lambda to the power 6 factorial. E to the power minus lambda will be common from both sides. Then we get e to the power minus lambda into lambda square by 8. 4 factorial means 4 into 3 into 2 into 1, right? And 6 factorial means 6 into 5 into 4 into 3 into 1 multiplied. So we get taking after 90 will be cut with them, and 9 and 4 will be after cutting we get this common, e to the minus lambda lambda square by 8, this common. So from both sides, e to the minus lambda will be cancelled. Lambda square will be also cancelled. So 2 factorial and 8 will be cut with what? 4. So we get 3 lambda square plus lambda 4, 4 into equal to 4, but if you take it in one side, then we'll get lambda to the power 4 plus 3 lambda square minus 4 equal to 0. Actually, this is the quadratic equation. If you can quadratic equation in lambda square, right? If you consider lambda square equal to x, then it's look like x square plus bx plus c types equation. That means quadratic equation. So solving for lambda square, we get lambda square equals to what will be minus b plus minus square root b square minus 4ac divided by twice a. That means b means what? Lambda square coefficient 3. Then square root 3 square, b square means 3 square plus plus 6 4ac. 4 means what? Only 4. Then a means what? Lambda square coefficient. Okay. Then constant minus 4. This one minus minus plus. Then we get plus minus this. Since lambda greater than 0, that means positive. So lambda square we get lambda square equal to, if we take positive part, lambda square equal to what? 1. Taking positive sign. Positive sign means 5 minus 3 divided by 2. That means 2 by 2. Lambda square equal to what? 1. So lambda equals to what? 1. Now mean equals to lambda equals to 1. So mu2 variance. Mu2 equals to variance. Variance equals to lambda mean. Variance equals to mean. According to what? Poisson distribution. We have proved it in our previous lecture. That means first part of Poisson distribution. So variance equals to what will be? Mu2 equals to lambda, also 1. Now we know beta 1 equals the coefficient of skewness. Coefficient of skewness equals to what? Mu2 square. Mu2 square divided by what? Mu2. Beta 1 coefficient skewness 1 by lambda. So this is the actually 1 by 1 equals to 1 result. Very easy. Previous class we have proved this maybe. So that in a Poisson distribution with unit mean deviation about mean is 2 divided by e times the standard deviation. In previous class we have proved this result. Okay, is it right? In previous class we have proved this. Is it right? Hello. This is actually solved in previous class. This example, after correcting 50 pages of the proof of a book, the proofreader finds that there are on an average 2 errors per 5 pages. How many pages would one expect to find with 0, 1, 2, 3, 4 errors in 1000 pages of the first print of the book? Actually, we have studied about look like example of this in previous class. Let the random variables x, then the probability density function for the Poisson distribution. We get lambda is the mean m equals to what will be 2 by 5. 2 by 5. Okay, this is the 2 errors per 5 pages. So we can take mean what? 5 by 2 by 5, right? 2 divided by 5. This is the mean 0.4. Now using probability density function for the Poisson distribution, p of probability of x, p of x will be e to the power minus lambda to the power x divided by x factorial. Just putting lambda equals to what? 0.4 here. The expected number of pages with x error per pages in a 1000 pages. Okay, if we want to find out the probability for 1000 pages, just we have to multiply with this 1000. Understand? Now we can make column, 3 column, look like before example. up to 0 to 1 0 4 and putting x equals to 0 in this probability density function, we get this result. And putting x equals to 1 in this probability density function, we get this. Just multiply it. This will be approximately what? Multiplying it with 1000, right? We get 670, approximately 670. If we put x equals to 1 here, a probability of 1 will give this result. Multiplying with 1000 will give 268, approximately what? 268. So if x equals to 2 in this, we get what? Probability of 2 will be give this. After multiplying 1000, we get this 54, approximately 54, right? 53.6. This is why approximately 54. Then putting x equals to 3 in this probability density function of Poisson distribution, we get this result. After multiplying 1000, we get 7, approximately 7. This. Now for 4, x equals to 4, we get probability density function for Poisson distribution. P of x equals to this, and after multiplying with 1000, we get this. This is approximately actually 1, right? And this is the actually expected number of pages, 1000. Okay, and this is the actually frequency also. Can you do? So this example, fit a Poisson distribution to the following data, which given number to rodents in a sample of clover seeds, 0 to 8 actually, number of x, and observed frequency will be this. Mean will be, we must know summation fx. This is the x, this is the x, summation fx will be this multiply this multiply this multiply this will be give the result total sum this. So dividing with total number of frequencies, if we add, it will be 500. So mean will be lambda or m equals to 1.9. Then Poisson distribution will give the Poisson distribution p of x equals to e to the minus lambda to the power x factorial, and x will be 0 to infinity. So probability of 0 what will be? 0 will be this result. E to the power minus 1.972. This is e to the power minus 1.972. If we take 10 based log on both sides, then actually we get this result. Actually this result can be found by calculator, right? E to the power minus 1.972 will give this result, probability of 0. Now using the you will try it at home, actually using the recurrence formula, if you can do. Okay, this is the last maths for you, if you try it at home. Okay, next day we'll study normal distribution. Okay, today is the end of the what? Poisson distribution. This is the last class for Poisson distribution, and next class will be normal distribution, first part. Okay.
Yes, sir.
Okay, till then, bye for today.